Welcome back, learners. In the previous lecture, so we have completely understood the each and every step of our design of the concentric isolated footing, right? So in the previous lecture I informed you that in the next lecture we are going to learn how to develop the Excel sheet for this. Now, so by developing the Excel sheet, we have to go as per this design steps itself. So let us take this fresh Excel sheet, okay, and let us give the name as this. So we are doing the concentric isolated footing. Let us give that name. Concentric isolated footing, right? So now, whenever you are designing this for the footings, right, keep it in mind, students should always try to design in such a way that your values should be, or your each and every step whatever is present here, it has to come here like this, okay? And so that since you will be having so many number of columns, so you can give the each and every footing values, okay? So therefore you have to start from here. Now according to this, what is my first step? My first step is the grade of concrete for the footing. So this is my input value, right, in Newton per mm square. So whichever is the input values, so I will try to write them in italics, okay? So the first that I have to give is grade of concrete, right, and usually this will be given in Newton per mm square, okay? And whichever is in whichever the input value is there, so I will make it in the italics part, okay? So the first step is giving the input value, that is grade of concrete, okay? So the next step is axial load on the column. That also we are supposed to give from the software, right? That is also input. That is, let us take, right, axial load on the column, right? So that will be given in kilonewton, right? So that will be given in the kilonewton. This also we will make italic, because in order to make clear that this is also an input value, okay? Yes. So the next step is self weight of the footing, right? Okay. Now next is self weight of the footing, right? The self weight of the footing will also come in kilonewton only. This is also, this is not an input value, this is an auto calculated value, okay? This is the one which will be calculated, no need to enter by us, right? Then how to do that? So first let us take one simple example here. So let us consider that the grade of concrete that I am going to use for my footing is 25, which will be in Newton per mm square, right? So for the sake of understanding, let us consider that the axial load on the column in kilonewton be, let it be 1000, okay, or let it be 700 kilonewton. It is the axial load on the column. Now we told you the self weight of the footing will be taken as the 10% that of the axial load, right? It means what I can do is I can give the formula here in the Excel sheet. Whenever I want to give the formula, I should always start with equal sign, right? I should always start with the equal sign. Then after that, 10% means it will be 10 by 100. So therefore I will open two brackets like this. So in the first bracket I will give 10 divided by 100, because it is 10%. So then I will close the bracket, multiplied by, right, my axial load on the column. So that you just click on this cell. Now you can see that the 10 divided by 1000 multiplied by C3. C3 represents your nothing but your this column. Okay, C3 represents that this column number 3 and corresponding the row number 3, right? That is what C3, that is column 3 and row number 3. Okay, C column row number 3, that is C3. Then I have to close one more bracket. You can see here, once all the brackets are closed, otherwise it will show an error. Bracket is not closed because you have opened two brackets, but you have not given the another. Once you close it, it will be proper. Then you just give enter. You can see here the 10% of your axial load, that is 700, will be 70 kilonewton, right? So like that, what I have done, I have created the formula, right? So wherever, for example, if you enter 800, you can see automatically it becomes 80. If you enter 1000, automatically it becomes 100. So like that, if you given the formula, so automatically it will take. So now I have given 700, therefore it will give 70, right? Like this. So 10 by 100 into column C row 3, right? Okay. So once the self weight is given, what is my next step? I have to take the total load for the design. The total load is nothing but your axial load and self weight. This is also adding. So therefore I can again develop the formula. So total load on the column. So that will be again in kilonewton only. So that will be this 700 plus 70, that is axial load plus self weight. So I can give the formula equals, I'll open one bracket. So I'll click on this cell plus I'll click on this cell, right? Then I'll close the bracket. That is column C row 3 plus column C row 4. You just give enter, will give you the total load on the column. Okay, yes, so that is my next step, right? So after that, after getting the total load on the column, which is in kilonewton, next is moment at the base of the column. This is again an input value, right? Moment at the base of the column, right? Moment at the base of the column, right? So that will be input value, which will be given in kilonewton meter, okay, which will be given in kilonewton meter, right? So that is an input value, therefore let us make it as inclined. Okay, let us make it as inclined. And I told you here we are considering only axially loaded column without any movement, so therefore I can enter the value 0 here, right? When I take up another type of footing design, there you will get the another value, right? So therefore it is 0 here. Then next you have is safe bearing capacity of the soil, that is also input in kilonewton per meter square. You have to get it from the site inspection. So therefore I can write safe bearing capacity of soil, which will be in kilonewton per meter square, right? So this is again an input value, right? I have to give the value. Let us give the safe bearing capacity of the soil for the sake of understanding as 300 kilonewton per meter square. So once you get the safe bearing capacity, your next step is calculating the approximate area of the footing, right? So approximate area of footing, right? This is not an input value because we have to calculate this. So your approximate area of the footing will be in meter square, right? Approximate area of the footing will be in meter square. So how you get the approximate area? The axial load on the column okay, divided by, that is the total load of the column divided by the safe bearing capacity. Therefore, I can give the formula equals, I need this divided by safe bearing capacity 300. I'll close the bracket, I'll enter. So that will give you 2.566. Okay, so 2.566. Now, whenever we do this, the next step is we will calculate the longer dimension of the footing and shorter dimension of the footing. Since your area of the footing, what you got, is in decimals, even definitely your the shorter dimension of the footing as well as the longer dimension of the footing also, they'll get it in form of decimals only. But usually we don't keep any decimal dimensions in the site, we will round it off to the next higher number. Okay, so therefore what I'll do is, I'll do one thing. Yes, so next is what I'll do, so better whichever is the input values, let me highlight it some by some color, let's say green color. Okay, so green color indicates input value. So approximate area you will get. So your next step after that, finding out longer dimension of the footing, that is capital L, right? Longer dimension of the footing. Okay, longer dimension of the footing. So if you have a doubt, what you can do is, I'll just insert one column and I'll give the notations to them. So grade of concrete is usually given by FCK, then axial load on the column is usually given by P, right? The sulfate, nothing is given. The total load, you can give it as this can be given as small p, the total load can be given as capital P, right? Then moment at the base usually given as m naught, okay, sorry, m naught, or you can give it as m, and safe bearing capacity is given by S, B, C. Then approximate area of the footing is capital A, then longer dimension of the footing is given as capital L, right, which will be in meter, right, which will be in the meter, right? Yes. Then, so how you get the longer dimension? The longer dimension of the footing L is given by 1.5 times, the shorter dimension of the footing I have to first calculate, so I have to calculate shorter dimension of the footing, that is capital B, so which is square root of the approximate area by 1.5. So then how to apply square root here? I will tell you. If you click SQRT, SQ, first you have to give equals, then just click SQ, you can see here the square root will appear. So click on this square root, okay, click on this square root, then you open the bracket, it will give you SQ, open the bracket. So in the bracket, you know, it is approximate area by 1.5. So therefore approximate area of the footing is this one divided by 1.5, and close your bracket, give enters, right? I think somewhere I made a mistake. If mistake is there, then it will show like this. So what you have to do, you have to go SQ equals SQ, okay, SQRT. Now it came, double click on that, it will come SQRT. In the bracket it is this divided by 1.5, close the bracket, give enter. So you got now. If you click on that, it will show you SQRT. So D column row 8, right? So that will give you 1.38. So you can, what you can do, you can round it off to 2 decimals, right? Then once you get the shorter dimension, you can get the longer dimension also, right? You can get the longer dimension of the footing as L in meter, right? So then as per this, how to get the longer dimension of the footing? 1.5 times the shorter dimension. It is bracket open 1.5 into your shorter dimension is this, give enter, will give you 1.96. Now you can see that your shorter dimension is 1.31, which is an decimal value, right? Then even this 1.96 is also a decimal value. Usually we round it off to the next higher dimension. Therefore, we will round it off to the next higher dimension, and whatever your round off value is there, that round off value only we will use for our further design. Okay. Therefore, I can type it as shorter dimension. Okay, then I can type longer dimension, right? Shorter dimension, longer dimension, right? So therefore what I can do, I can write it, this is also in meters only, right? So this is B, capital B, this is capital L. So this value we have to input, we have to give, because the software will not round it off to the next number. You have to give the input. When it is 1.3, let us make it as 1.5, and when it is 1.9, let us make it as 2. Okay, and since this is an input, again, and not only that it is an input, it is the one design value which we require. So whenever you have a major design value, so let us highlight it. Okay, let us highlight it like this. So when you highlight this, so then what will happen? So this becomes that it is a step. You will come to know that, okay, it is an higher right. So this will give you that, okay, this is the design steps I need to know, right? So this is my shorter dimension and longer dimension. So once you get shorter dimension and longer dimension, with the help of your SBC of the soil, you have to calculate maximum pressure and minimum pressure. Now you can see here, in order to calculate maximum pressure, you have two components here. One is axial loading, one is this part, another one is this part, right? So now, even in order to find out the Z also, you have a separate formula. So instead of considering everything in one formula, which may have a chances of mistake, so let us write the formula for one step, and finally we will get maximum pressure. It means first I will write the formula for Z. Okay, first I will write the formula for Z, right? So the Z I will write. What it is actually, the Z is called as a yes. So we will find out the value of Z here. So Z, right? So Z, you will get the dimension in mm to the meter cube. Okay, so that is so it is m cube. Okay, it is m cube, right? So now first I need BD square by 6. So what I can do, enter, I will give two boxes. First I will select B, that is this one, multiplied by D square, this one, again this one, I will close the bracket, divided by 6. So that will give you directly your value of D. Okay, that will directly give the value of D, right? So what is that? It is 1. Okay, it is 1.5 into 2 into 2 divided by 6 will give you your BD square as 1. Right, so you got the value of Z now. Then you write down moment at the base and divided by Z. Okay, that is one component. So I calculated Z here. Then you can write moment at the base divided by Z. Right, so moment at the base divided by Z. So usually what it will be, moment at the base will be kilonewton meter, Z will be meter cube. So then meter will get cancelled, you will get it in kilonewton per meter square, right? You get kilonewton per meter square, and no symbol for that, it is just a part, right? So therefore what you can do, equals to the moment at the base I have given 0 divided by this, right? It will be 0. Then next you have one more part, that is axial load by area of the footing, right? So for that also you can write total load divided by area of the footing. But make sure that students, learners, here when I round it off this number to the higher dimension, your area of the footing will change. Therefore let us insert one column and let us write final footing area in meter square. Okay, final footing area. So let us give that as A dash, and let us give that as m square is the unit. So that will be this into this, right? So that will give you 3, right? You can see your approximate area of the footing was 2.5, now it is 3, right? Okay. So now I need I can write it here, area means final. Okay, I can write final area, right? So that is also, it is a part, no need to have that. So that is again it will be in kilonewton per meter square, right? So therefore it will be your total load on the column divided by my final area. So this will be your this part. And after that you can have the maximum pressure Q max. So therefore here I can write maximum pressure given as Q max in, it will be in kilonewton per meter square. So what is that value will be? It will be sum of this plus this, right? So that will be your maximum pressure. Then similarly you can find out minimum pressure, right? That is your Q minimum, so which will be the same unit. So that will be this, sorry, that will be this minus this. Okay, so here maximum pressure and minimum pressure both are one and the same because we are not taking moment. Okay, yes, that is about your maximum pressure and minimum pressure, right? So once you got this, you got both maximum and minimum pressure in kilonewton per meter square. So the next is the input value, that is shorter dimension of the column. That is shorter dimension of the column, that is an input value. Shorter dimension of the column, which will be given as small b, and it will be in, let us give it in mm. Usually it will be given in mm because the length will be very small, right? So let us give the column length shorter dimension as 250 mm. Okay, shorter dimension of the column. And next you have longer dimension of the column. So that will be, this is B, that is small l. Okay, that is small l, which will be given in mm, and that let us give it as 400. Okay, so that is about, and you can make these two as inclined. Why? Because they are input, and let us make them in green color, right? Okay, so the next step is calculation of the critical section, right? Calculation of the critical section. So let us write the formula calculation of critical section X. Okay, yes, we can just write critical section of footing, right? So let us give that in the small x, and that will be in which unit? It will be in the meters, right? So what is that? It is longer dimension of the footing. Okay, so therefore I can give two brackets. So the longer dimension of the footing minus shorter dimension of the footing, I'll close the bracket, divided by, I'll open the bracket, 2, and since I want it in meter, I have to again divide it by them 1000. So that will give you one more bracket. So that will give you my critical section of the footing in meters, right? So when I do longer dimension of the footing, which is in mm, minus longer dimension of the footing minus longer dimension of the columns. So learners, just I made a mistake, so let me remove this, equals longer dimension of the footing, right? So this is the longer dimension of the footing minus longer dimension of the column. But you know the longer dimension of the footing is in meters, my longer dimension of the column is in mm. Therefore what I have to do, I'll just open one more bracket. So I'll select this, divided by 1000, so that there itself I can convert to meters. So now it is longer dimension of the footing in meters minus longer dimension of the footing in column. So I will close this bracket, so divide by 2, then again I will close one more bracket, enter. That will give you the critical section in meters. Okay, this is about my critical section. Let us make footing only, footing, okay. Sorry, this is yes, like this, right? So once you have this critical section, then your next step is finding out the bending moment at the critical section. Till here we will do, okay, bending moment at the critical section. Next step, so I can write bending moment at the critical section, right? So bending moment at the critical section, so I can write this as bending moment xx in kilonewton meter, right? Yes, how to calculate that bending moment at critical section? It is maximum pressure, that is Q max, multiplied by longer dimension of the footing, multiplied by 2 times the critical section. Everything is in meter. Okay, yes. So everything is in meter. So now I can give enter. I'll enter now. I need the maximum pressure, right? You can see here maximum pressure Q max. So maximum pressure multiplied by longer dimension of the footing. Okay, I have to take yes, I have to take, and it is not the longer dimension, it is actually the dimension perpendicular to that, that is my 1.5 multiplied by x 2 times into divided by 2, right, divided by 2. That will be your bending moment at the critical section in kilonewton meter. Okay, that will be your bending moment at critical section in kilonewton meter. And finally you have factored bending moment, right? Factored bending moment. So I can write this same thing here. You can write this same thing here. So here it is nothing but 1.5 multiplied by this value. So that will be your factored bending moment. So let us stop here, learners. In the next video we will write down the formula for the rest of the steps, and we will see how to bring all my ETABS software values to this and how to get the values. We will see that in the next video. Thank you, learners.